Welcome back, everyone, to Burton Math Unlocked. Today we're going to continue on the 2026 June Algebra 1 Regents. Last time I posted, it was just the multiple choice. Now we're getting into those extended response questions. As a reminder, for extended response, you should be writing in pen unless it is a graphing question where you need to draw on a graph. So if we start with question number 25, we're finding the product of 1 minus 2x and 3 minus 5x, and then from there writing the polynomial in standard form. First things first, we need to know that product means multiplication. So we're going to multiply both sets of parentheses together. I'm going to show two separate strategies of doing this. The first would be the FOIL method. So first, outer, inner, last. And then the second would be area model / box method for those who might need something a little bit more visual. Whenever we have two sets of parentheses next to each other, that automatically means multiplication. So we're going to multiply 1 times 3. Then we're going to multiply 1 times negative 5. Then negative 2x times 3. And then negative 2x times negative 5. Negative 5x, sorry. So 1 times 3 is 3. 1 times negative 5x is negative 5x. Negative 2x times 3 is negative 6x. And then negative 2x times negative 5x is positive 10x squared. First things first, I'm going to put this in terms of standard form before I combine the like terms, just so that whatever value has the higher exponent, so the exponent with the largest degree, comes first, and then my constant, the number that stands alone with no variables, comes last. So I'm just going to use the commutative property to do this. So 10x squared minus 6x minus 5x plus 3. From here, all we need to do is combine our like terms. So like terms are values that have as the same variable and same exponent, or they're constants. Here we have negative 6x and negative 5x, so we can combine. So we're going to bring down that 10x squared. And then negative 6x minus 5x is negative 11x plus 3. And this will be our final answer. If we were to use this using the box method, for those who like a visual, each set of parentheses has two terms. So we're going to do a 2 by 2 box. So create your box, split it up in half, and then in half again, so we have fourths. On the top of the box, I'm going to put my first two terms. So we have 1, and then we have negative 2. And on the side, I'm going to put the next set of parentheses, which is 3 and negative 5x. From here, all we have to do is just multiply, basically finding the area, length times width of each box, and then we can combine our like terms and write it in standard form from there. So 1 times 3 is 3. And then 3 times negative 2x is negative 6x. 1 times negative 5x is negative 5x. Make sure you don't forget your signs. And then negative 2x times negative 5x will be positive 10x squared. Same thing here. And then usually these two boxes are the ones with the like terms if you were to use this method. So we have 10x squared minus 11x plus 3. So same thing we got over to the left. Okay, next we have an absolute function, which are lovely. So these are typically shaped as the letter V, either going up or down. Here, since x is positive, we know that we're going to have a positive function or a positive looking kind of slope. And then we're subtracting 3. Since the minus 3 is outside of that absolute value symbol, we know that we're going to be going down 3. You could also put this into your TI-84. So under y equals, you're going to put an absolute value of x and then subtract 3 from it. From there, you can hit second graph, and that way it gives you the table of the values. But I'm just going to do it based off of my knowledge of knowing that square root of x minus 3 is just us doing the letter V going down. So each value is going up 1 over 1. So typically it will be starting at the origin, and then we just keep going up 1 over 1, like so. But here it's going to be quite different, like I said, because we have to make sure that we're going down 3. So we're going to take that origin part and go down 3 units, which means that each of these points needs to go down 3 units. So I'm just going to start it off at 0, -3, and then from there we can determine which points we need and which points we don't need based off of our domain here. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, and keep doing that. Question now is, when do we stop? In this case, given that our positive value for our domain is 7, that means we're going to stop where x is 7. So if we look, we're just going to count our boxes, usually 10 by 10. So 1, 2, 3, 4, 5, 6, 7. This would be our last point for our domain. We do not go any further than that. And then same on the other part of our domain, since it starts with -7 is less than or equal to x. We also need to make sure that the other x value stops at -7. So on the left side of our graph. So once again, start back at 0, 3. We're going to go up 1 over 1. So up 1 to the left 1. Keep doing that until you get to -7. From here, all you have to do is just connect your dots. Do not go any further than your last point, or you will get a point taken off because technically you're not in the realm of your domain. You want to make sure that your function stays within the proper domain. From here, I personally like to label my graph just so that I stay in the habit of doing so when it comes to inequalities. With the domain of -7 is less than or equal to x, which is less than or equal to 7. But that's it. So like I said, you can put this into your TI-84. It can do all of the work for you. And then just making sure that you keep within those domain values. So -7 for your x value and then +7 for your x value. You can't go past those. So anything in between works because those are any of those values in between for x. And then anything outside of -7, so like -8 or +7. So +8 will not work here. All right, number 27, we're going to solve the inequality algebraically. All that means is that we need to use the basics of algebra that you started learning in 6th grade to isolate x, aka get x by itself. So first thing I notice here is that we have a set of parentheses with a number directly outside of it, which typically means that we need to use the distributive property. So we're going to distribute the 3 to the 2x and then 3 to the +1 and just rewrite that inequality. So we have a -4x plus 1 is greater than 9 plus 6x plus 3 plus x. From here, we can combine like terms. So I'm going to check the left side. There are no like terms, but on the right side, I notice that there are a couple of like terms. I'm going to rewrite it first just to make it easier for those who are visual. So we're going to use that commutative property once again. So we have 6x, which is a like term with x. And we have 9, that's a like term with 3. And then from here, we can just combine those together and rewrite it. Once again, don't forget your signs. In this case, all those values on the right side of the inequality are positive, but there can be times where they're negative. So making sure you don't forget that subtraction sign in front, aka the negative sign. So you have -4x plus 1 is greater than 7x plus 12. From here, we want to make sure that our variable stays on one side of the inequality symbol and then our constants stay on one side. I personally like to make sure the variables stay on the left side and then the constants stay on the right side. And in order to do so, we have to move those variable terms. So 7x is on the right side with a constant. We don't want that there. So we got to move it over to the left side, which means that we have to do the inverse operation. Since 7x is positive, we're going to do -7x, and whatever we do to one side, we must do to the other, just to keep our inequality balanced, aka equivalent, which means these two 7x's cancel out, and we're left with -11x plus 1 is greater than 12. So that's good. We move the variable term, but if you notice, we have a constant term on the left side that we need to have on the right side. So since it's a positive one, we're going to do the inverse of that, which would be subtract 1 or negative 1. And whatever we do to one side, we must do to the other, just to keep it balanced. So those ones cancel out. And now we're left with negative 11x is greatest or greater than 11. This comes the part that gets a little bit tricky for some students, but if there's ever a leading coefficient in an inequality that's negative, the easiest way of explaining this is that we have to flip the sign. So first of all, let's get 11x by itself, or x by itself. So we're going to divide both sides by negative 11. And because we're dividing by a negative term, we're just going to change that greater than sign to its opposite, which will be a less than symbol. So these two negative 11s cancel out, and now we have x is less than negative 1. And this will be the final answer. You could also rewrite it as negative 1 is greater than x if you wanted to. Both mean the same thing, just written in a different order. Question number 28. We have the formula for the area of a triangle, and we're solving it in terms of a and b, which means that we need to isolate h. So h is that term that we want to get by itself. So at the end, we want to see something in the form of h equals whatever our expression is on the other side. So we have the area of a triangle equals half the base times height. Knowing that we're trying to isolate h, I'm going to keep her highlighted because she's the last term we want to touch right now. He, she, they. And in order to get some of the other terms by itself, I usually start with the value or the number that's there. We have 1/2, and in order to move that 1/2, we can divide both sides by 1/2, but I personally like to multiply both sides by the reciprocal of 1/2. So for example, reciprocals of like 2/3. My computer is deciding to freeze. The reciprocal of 2/3 would be 3/2. The reciprocal of 4/5 would be 5/4. And then the reciprocal of 2/1 would be 1/2. So we're just flipping those fractions in case you didn't know the term. So on the right side of this equation, I'm going to multiply both sides by 2. Because anytime you multiply a reciprocal by its reciprocal, we get the value 1, so cancel out. So this 1/2 cancels out now. So now we have 2a equals base times the height. If we notice h still isn't by itself, a equals bh rather than h. So in order to get h by itself, we're going to divide both sides by b, since b is being multiplied by h. So we're just undoing operations right now, which cancels out those b's on the right side, which means that now we're left with 2a over b equals h, our height. And this would be our final answer. So you can leave it in terms of this, or you could rewrite it as h equals 2a over b. Both work, they mean the same thing. Once again, just using the commutative property and switching the order. Next up, we have the population of Manhattan over the years indicated according to the Census Bureau of the United States. And we want to find the average rate of change. Whenever we see average rate of change, which shows up every single Regents test, sometimes multiple choice, sometimes it's open response, usually open response, but you never know with the multiple choice ones. We're just going to look to see what values it wants us to find the average rate of change for. So in this case, it wants us to use years 1980 and year 2020. And we'll come back to this rounded part because that will be very important for us at the end. Given that we need to use years 1980 and 2020, I'm just going to highlight those because these are the only values that we need to touch. And if you remember with the table, our first value is usually our x values, our second is usually our y values. And I say that because average rate of change, we're going to use the slope formula. The slope formula is y2 minus y1 over x2 minus x1. So in this case, y2 would be this lovely big number over here. And, oops, I wrote y1, my fault. This would be y2, which also means that this is x2. And then 1980 is x1. And then that lovely big number next to it would be y1. So all we're going to do is plug these values in into our formula for slope, and then that will tell us our average rate of change. So we have y2, which is 1,643,734, subtracted by 1,428,285, all over x2, which is 2020, minus 1980. And then we can use our calculator from here to do all the work, but that subtracted in the numerator, so our y values will get us 215,449, and then 2020 minus 1980 will get us 40. Once we simplify from here in our calculators, you should get a number. If it says to the nearest integer, it's the nearest whole number, which means that our answer is approximately going to be 5,386. Just making sure you're rounding to the nearest whole number. Okay, question 30. This type of question does not show up often when in the sense of the denominator is an irrational number and it's asking you to write it in a rational denominator. Typically, it'll ask you if the product of these two numbers is rational or irrational, or if the sum of these two numbers is rational or irrational. So this one was a little bit of a mix-up for a lot of students taking the test, but it is a lot simpler than it seems. So in order to create a rational denominator, we have to get rid of that root symbol in our denominator. So we have the square root of 3. The only way for us to get rid of that root symbol is to multiply by the same square root. But whatever we do to one part of our fraction, we have to do to the other. So if we multiply our denominator by the square root of 3, we also have to multiply our numerator by the square root of 3. So then anything times its square root will just be the number underneath the root symbol. So for example, square root of 3 times square root of 3 is just going to equal 3. So that will be our denominator. 3 is a whole number. There's no decimal behind it, no run-on number, which means that it is a rational number. And now we have 5 square root of 3 at the top, which we can just rewrite as 5 square root of 3 since they're being multiplied. And this will be our final answer. All we needed to do was create a rational denominator, which meant that we made an irrational numerator, which is completely okay. All right, next up, part 3, which gets us into our 4-point questions. Typically, we have a question like this one, which can always be done in the calculator. I 1000% recommend you do these types of questions using your TI-84. So in the TI-84, and I'll pull that up for us, you're going to go to y equals, and within y equals, we're going to type in that equation that was given to us, which was d of t equals negative 16, and it says t squared. We're not using t, so we just say x squared, and then plus 32t, so plus 32x plus 48. From here, we can just graph it, but if you notice, it's very difficult to see the graph. So we can look at our values on the table that's given to us. And if you notice, it's going all the way up past 100. So we're just going to zoom out towards 100. So we're going to say second zoom, oops, window, and then for your x value, we're going to change this to being about 100 instead. And now we can go back to graph and it should zoom that out for us. So that's what our graph should look similar to, but also if we hit second graph, that will get us the table that we need to use in order to figure out what we need to graph from here. And if you notice, so for our table, our t values, the ones at the bottom, go up until 5. So this first number is 0, this last one is 5, which are also our x values. So we only need to go from 0 to 5 and no further, because there's no space to go any further. So our x values, which would be our time, and then our y values, which would be our feet. So we have 0, 1, 2, 3, 4, and 5. And in our TI-84, we notice that with those values, 0 is 48, 1 is 64, 2 is 48 again, 3 is 0, 4 is negative 80, and then 5 is negative 192. So we're going to just transfer that information over and write the same thing. So 0 is 48, 1 is 64, 2 is 48 again, 3 is 0. I'm not going to write the others only because we can't get into the negative values for our graph. So we're just going to stop at that 3 instead. And now we just plot our points. So we have 0, 48. We have 164. 2, 48. And then 3, 0. From here, we just connect our dots for our graph. It doesn't have to be perfect. Whoever's scoring it knows exactly what you mean. And then we can solve. So we need the maximum number of feet above ground that the ball will reach. So the maximum number of feet being the keyword and the max. So what is the tallest value that our ball can go? And from there, that means we need to look at the height in feet, so the y values. And the biggest number here would be 64, so this is going to be our max. So our max is 64 feet. You can write it in a complete sentence. Honestly, doesn't matter. And then next, we need to state the number of seconds after the toss, and it will make the ball hit the ground. If a ball hits the ground, that means we're at level 0. And we're asking for the number of seconds. So since we're talking about time in seconds, we want to make sure that we're using our x values. So which one of our x values, what is that value going to be when y is 0? The only place where y is 0, so hitting the ground, would be 3. So it's going to take 3 seconds for the ball to hit the ground. Which we can also see in our graph, because this point is 3, 0. And then our max here is 164. Next up, we are solving a systems of equations, this time algebraically, but we're solving for the values of x and y. This is a tedious question because we need to set the equation equal to 0, and there's going to be a little bit more work than typical. So first thing we want to do, since both equations equal y, and from what you know of systems of equations, we can just set both equal to each other. So we're going to rewrite this as negative 2x plus 3 equals x squared minus 5x plus 3. From there, we want to move the terms all over to one side so that we can, once again, like I said, set it equal to 0. I'm going to move my constant term first. So since I have positive 3 on the left side, I'm going to subtract 3 from both sides. That way we can move that constant term. And now we're left with negative 2x equals x squared minus 5x. And then those 3's cancel out over here as well because positive 3 and then negative 3 creates 0. Next up, we want to move this negative 2x because like I said, one side needs to be 0. So in order to do that, we're going to add 2x to both sides. Which cancels out the left side, leaving us with 0 equals x squared minus 3x. This is where it gets a little bit doozy. So if you understand completing the square, the only value that can multiply together to get us negative 3 would be negative 1/2 or 1.5. So we will rewrite this as x minus 1.5x, 1.5 squared equals 0. And then our next step would be getting that 1.5 over to the other side. So if you ever did this, you would get x minus 1.5 squared in parentheses equals 2.25. Because we have this equation now where one side doesn't equal 0, we want to be able to get x by itself. In order to do so, we have to undo that square that we have on the left side. In order to undo the square, we're going to do the square root, because that is the inverse, and whatever we do to one side, we do to the other just to keep them equivalent and balanced, which means now we have x minus 1.5 equals square root of 2.25. And I'll go over how I got 2.25 in a moment. Square root of 2.25, you put that into your calculator, we will get x minus 1.5 equals plus minus 1.5. And since we still need to isolate x, we're just going to add 1.5 on the left side to both sides to get x by itself. So now we have x equals 1.5 plus minus 1.5. So we're going to have two values of x here that we could use, and one being 1.5 plus 1.5, or we could do 1.5 minus 1.5. 1.5 plus 1.5 will make x equal to 3, and then 1.5 minus 1.5 will make x equal to 0. Since we know our x values, we're going to substitute those back in, and then from there we can solve for our y values. So we have y equals negative 2 times 3 plus 3, and we have y equals negative 2 times 0, because the other value of x is 0, plus 3. And then from here you can use your calculator to simplify. I'm just going to write it out. So y equals negative 6 plus 3, which means that y equals negative 3. And then we have y equals 0 plus 3, which means that y equals 0. So our first solution set for this, if x equals 3, y equals negative 3. So we have 3, negative 3. And we have when x equals 0, y equals 0. So we have 0, 0. So we're just putting those values together. Sorry, not 0. It should be 3. Good thing I caught that mistake. Calculator would have caught that for me, but caught it myself. Alright, when we're talking about completing the square, for those people who might be confused about how I got 2.25, we have currently x squared minus 3x, and we need to fill in the blank with some other value here. And in order to figure out what that value is, we usually take our b value and then divide it by 2 and square it. So b divided by 2 and then square that, and that will give us the value of c. So -3 divided by 2 and then square that would be -1/2, 1.5 squared. -1.5 squared will get us 2.25, which is how we got that 2.25 over here. And that works every single time you do completing the square when you're trying to find your third value, so your c value. Next up is one of my easy 4-point questions, which is a linear regression. It's not taught as often in schools anymore. Why? Good question. I don't know. I don't like teaching it myself, to be completely honest. But it is easy to get completed in the calculator. So since we know our values for the calculator, which I will make the screen a little bit smaller, all we have to do is go into our online TI-84. But first thing we need to do when it comes to linear regression is we want to go into our mode and making sure that our stat diagnostics down here is turned on. Your calculator will be reset before you get it, so you're just going to scroll down to on, hit enter, and then from there we can click stat. Once you're in stat, we just want to be in 1, so you're going to hit enter, and we're going to put in our values from our table that we had. So our first value is 2, then 3, 5, 9, 13, 16, and then we're going to go over to the other side. Oops, did not mean to do that. We're going to go to L2 and type in our y values, which is 15, 28, 42, 54, 64, and 90. Okay. Once we put in our x and y values for L1 and L2, we're going to go straight back to stat. And instead of hitting edit this time, we're going to go to calc, and then we're going to hit 8 because we want to figure out our linear regression. Once you hit 8 or scroll down to hit 8 and hit enter, we're going to enter all the way through to the end, which won't take long to do. Once you get all the way to the end, you're going to be given our linear equation formatting. So the formula, which is y equals a plus bx, the value of a, b, r squared, and r. In cases like these, we do not need r squared. And then in this part of the problem, we do not need r. We will need that for part b of this, though. So we have our equation, which is y equals a plus bx. So we're just going to plug in those values. But typically, it wants you to round to the 100th place, which is the case here. So we're going to set it up as y equals. Since a is 11.93 repeated, we're going to take that 9, look next door to that 3. That 3 is in the 100th place, which means that we need to look to the right of her in the thousands place. Since it's below 5, our value is just going to be a equals 11.93. So the 3 will stay the same, and then we drop all the other numbers to the right of that 3. And then our b value, which is 4.6125. The 6 is in the tens place, the 1 is in the hundredths place. So we're going to look next door at that 2 in the thousands place. And since it's below 5, that means that the 1 will stay the same. So we have 4.61. All right, from here we just plug it into our equation. So we have y equals 11.93 plus 4.61x. I don't know why my plus sign is so fidgety. And that will be your answer, rounded to the nearest hundredths. For the correlation coefficient, all we need is that x value, the r value. And once again, we want to round to the nearest hundredths. So we're going to find the value that's in the hundredths place. In this case, it's the 7, because we have r equals 0.9755. Then look at this 7, then go next door. Since it's a 5 in the thousands place, that means we need to round our 7 up 1 notch, so it will turn into an 8. So our correlation coefficient is actually going to be 0.98. And that would be your answer after you round to nearest 100. And lastly, we just need to figure out what the correlation coefficient will be. So if our R value, so our correlation coefficient, is closer to 1, that means it's strong. And then if it's closer to 0, that means it's on the weaker end. So here we'll just say the correlation coefficient, since 0.98 is closest to 1, we're going to say is strong. And that's what it indicates about the line of best fit. And question number 34. Gonna do some more inequality work. This is a good 4-point question that shows up every single year. They never miss a beat. First thing I like to do is write mine in slope-intercept form, so in the form of y equals mx plus b. So we have 2y is less than x minus 8. In order to get y by itself, we need to divide everything by 2. So it will be y is less than 1/2 x minus 4. And the value that's in front of x, or the coefficient of x, is going to be our slope, so m equals 1/2. And then our y-intercept, or our point, is going to be 0, -4. And we're going to do the same thing with the other inequality, so 3x plus y is greater than or equal to 6. And we want to get y by itself, so we need to subtract 3x from both sides. But once again, I want to make sure it's in slope-intercept form as I'm doing this, so in the form of y equals mx plus b. So we have y is greater than or equal to -3x plus 6. Which also means that our slope, let me correct that, our slope is -3/1, because -3 as a whole number, or as a fraction, is -3/1, and then our point is going to be 0, +6. What I do also notice is that our first inequality has a less than sign, which means it's going to be a dotted or a dashed line. And then our second one is greater than or equal to, which means that's going to be a solid line. If you have the incorrect lines, you will lose a point. And you don't want to make too many errors, because if you make too many errors, you don't get those points back. So let's start with the 2y is less than x minus 8. So we're going to start at 0, -4, which is our y-intercept. And then we're going to go up 1 and then to the right 2, since it's a positive slope. And you're just going to keep doing that until you run out of space. Since I still have space on the bottom, instead of going up 1 to the right 2, I'm going to go down to the left 2 to fill up the extra space over there. And as we stated, we needed a dashed line. So we're just going to dash it out. You will be given a ruler for your Regents, so you can use the ruler if you'd like. I'm also going to label this while we're here as the inequality. So 2y is less than x minus 8. At least one of your inequality lines needs to be labeled. It doesn't have to be both. I do both just to be safe, but one of them needs to be labeled. And then for the second, we're going to go to 0, 6. And then we're going to go down 3, because our slope is negative, and then to the right 1. And you're just going to keep doing that. Down 3 to the right 1, down 3 to the right 1. Since we have space at the top, we're going to go up 3 and then to the left 1. And as we stated, for this one, our line is solid. So we just want to make a solid line through those points. And once again, I'm going to label her. So she is 3x plus y is greater than or equal to 6. It's usually the part where we have to shade that gets a lot of students confused. And I personally find the easiest way to shade is to use our origin. So we're going to use 0, 0, and we're going to plug it into both inequalities. If it is true, where something like -3 is greater than 0, we're going to shade in the side of that line that has 0, 0 included. If it's false, we're going to shade the side that does not have 0, 0 included. So, for example, we have 2y is less than x minus 8. So instead of y, we're going to plug in 0. So 2 times 0 is less than 0 minus 8. 0 is less than -8. This is not true. -8 is actually less than 0, which means that for this inequality, so our dashed line, I'm not going to shade above, because if I shade above, that's going to include the 0, 0. We're going to shade below that line so that it doesn't include that 0, 0. And then same thing with our other inequality. So instead of writing 3x plus y is greater than or equal to 6, we're going to plug in the variables with 0. So 3 times 0 plus 0 is greater than or equal to 6. Three times 0 is 0 plus 0 is 0. And this also isn't true. 0 is not greater than 6. So if we're looking at our other line, we're going to shade in the part that does not have 0, 0. 0, 0 is right here. So we don't want to shade in that side. We're going to shade in the side that's technically above. So we're going to shade over here. They don't typically ask you to label the part that satisfies your solution set anymore, but if they did, that would be this lovely area over here. I'll actually do that in a black highlight. And that would be all the values that satisfy our solution set, which makes both inequalities true. So now we just need to pick any value within that blue and green shaded part, any value you want to satisfy, and then to justify, you can show your work, or you can just explain that it satisfies both solution sets. So for me, let's do whatever this point is. Why not? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5, -4. And then now we just want to check to make sure it's true. And this is the way I'm going to justify my answer. So let's start with our first inequality, and then we'll get into the second inequality after. So 2y, so 2 times -4, is less than x, which is 5, minus 8. And then our other one, which is 3x, which is 5, plus -4, is greater than or equal to 6. 2 times -4 is -8. You could also put this into a calculator. And then 5 minus 8 is -3. -8 is less than -3, which is true. So then the other one is 3 times 5, which is 15. Minus 4 is greater than or equal to 6. 15 minus 4 is 11, which is greater than or equal to 6, which is true. It satisfies both inequalities. You do not have to write out a full explanation like I did. Completely up to you. But you can pick any of those numbers that's within here. And my pen is deciding not to work. Any values in here. I would not pick the values that are directly on the lines we drew, but anything in between there should work. I would just check it just to be sure you didn't type anything or write anything improperly. Okay, last up, our 4-point question, which is typically the same, but this year they did have us graph it. No biggie, still quick and I wouldn't say easy to do, but not as difficult to do. So I personally like to color code everything or box things a certain way and then put different shapes around things. So a department store is in a tax-free state. Jane can either buy 3 tank tops, so that's important, 2 sweatshirts, I'm going to circle that one because it's different than the tank tops, for $52, our total, or our other equation here, 2 tank tops, and then 1 sweatshirt, and that is for a total of $30. So we have 2 equations that are given to us here, and I'll get into the next part in a sec, but let's write those 2 out. So we're going to start with the first part, where she can buy either 3 tank tops and 2 sweatshirts for $52. We know that X represents the price of 1 tank top, so I'm going to box that because they all represent the tank tops. And then Y represents the cost of 1 sweatshirt, so we're going to circle that because it matches with our sweatshirts. That was not a circle. Okay, so we have 3X, which is our tank tops. And then 2 sweatshirts. And usually if we're buying things, we're adding things up because we haven't been told of any discounts. And that's for $52, so $52 is the total that she spent. And then our other equation was if she were to buy 2 tank tops, so 2X, and then 1 t-shirt, so plus 1Y, or just Y, equals $30, because that's the total she spent on that. From here, after we write our system equations, we want to make sure that we are solving. So we can solve using any form of system equations, which would be substitution or elimination. I'm personally going to do, what should we do? Let's do elimination because it's usually easier for most people. So since both have a Y value, I'm going to multiply our second equation by negative 2Y. That way those 2's or the Y's eliminate. So we have 3X plus 2Y equals 52. And then we have 2X plus Y equals 30. In order to change this, we're going to multiply everything by negative 2. So now we have our new equations as being 3X plus 2Y equals 52. So our original, and then our second, after we change it, would be negative 4X minus 2Y equals negative 60. So all we do is solve from here. So these 2 cancel out, and we're left with negative X equals negative 8. We can't leave X as negative, so we're going to switch our sign and divide both sides by negative 1. Once we do that, those negatives cancel out, which means that we have X equals 8. Another way we could do this, so you'll plug that back in for the X values, is we can get Y by itself for both, so put them both in slope-intercept form, and then from there find our slope and our points. Completely up to you, but right now we just need that system of equations, so you don't have to go any further than just doing this. So I took you guys along another step, but typically it does ask you to solve using a system of equations, which would be your way of doing it. And if we wanted to finish this off, like I said, we'll plug 8 back in for X. So I'm going to use the first equation, so 3 times 8 plus 2Y equals 52. 3 times 8 is 24, plus 2Y equals 52. All we're doing here is solving for Y, so we know if X is 8, the value of Y. Subtract 24 from both sides, since 24 is positive, and we want to move it, and we're left with 2Y equals, I don't know, 52 minus 24 at the top of my head, 28. So then Y equals 14. So when X equals 8, Y equals 14, which is actually going to help us on the next page. Okay, so the next page we need to graph our systems of equations, state the coordinates of the point of intersection for your lines. The point of intersection we just did, so X is 8 and then Y is 14, but we're going to prove that by graphing it. To graph it, this is where that y equals comes in. So we're going to put our equations into slope-intercept form. Since we have all this extra space, why not use it? So we have 3x plus 2y equals 52. So if she buys 2 or 3 tank tops and 2 sweatshirts, she spends $52. We want to get y by itself, so write in the form of y equals mx plus b. So we're going to subtract 3x from both sides, which leaves 2y equals negative 3x plus 52. Y still isn't by itself, so we need to divide everything by 2, which is y equals negative 3 halves x plus 26. That's our first equation. Now we need to do the second. So the second one is if she has 2 tank tops and 1 sweatshirt for $30. So we have 2x plus y equals 30. And we want to get y by itself, so we're going to subtract 2x from both sides. So y equals negative 2x plus 30. Now that we have these, we know that the slope is negative 2 over 1. That does not look like a negative sign. And then our point is 30, 0. Sorry, 0, 30. And then for our equation up above, m equals negative 3 halves. And then our point is 0, 26. And that will help us below when we're graphing them. So I'm going to start with the first one, which is 0, 26. And I'm going to go down 3 over 2. So go down 3 to the right 2 again. Down 3 to the right 2. Down 3 to the right 2. And you're just going to keep doing that until you run out of space. Beautiful. Since it's an equation, we're just going to keep a solid line. And then I'm just going to label these as usual. So this is our equation, 3x plus 2y equals 52. And then we just need to do the other one. So 2x plus y equals 30, which our slope is negative 2 over 1, and our y-intercept is 0, 30. So we're going to start with 0, 30. And then we're going to go down 2 to the right 1. And just keep doing that until you run out of space. And now we can connect those lovely dots once again. And this equation, or these equations, are done. And the point where they both intersect was 8 and then 14. So the point that they both had in common, which is the same we got below. Okay, so now all we have to do is just explain it in terms of the problem. So we're talking about money. So if 8 is our X value, that's also going to be the cost of the tank tops. And then 14 is the Y value, which would be the cost of the sweatshirts. So we can keep this simple. So $8 is the cost of one tank top. And $14, same setup as the problem above, is the cost of one sweatshirt. There goes the entire test. As I said, for question number 35, usually just ask you to solve with a systems of equation, which is what we just did, and that also helped us on the next page. But in this case, since it's asking us to graph it, it's easier to graph if we're writing our equations in slope-intercept form, which is the second step we did here to solve. As always, if you do have any questions, please feel free to leave a comment below, like, subscribe if you like to. I will make sure that I am submitting more of these a little bit more often, especially given that you do have a Regents next week. But if there's any Regents tests that you would like to see, I can submit some geometry, some Algebra 1, Algebra 2, whatever you would like, let me know in the comments below, and I can make sure to get those uploaded for you. Good luck on your Regents test. Good luck with your Algebra 1 scores. You guys got this, and I will see you the next time.